Alright, so carrying on from the previous video where we looked at the R value of the PMCC value, we're now going to be looking at whether we can do a hypothesis test for zero correlation. So what this means is if we have a sample of like X and Y values and we can work out our PMCC value using the calculator as we just looked at in the previous video, we can now suggest, oh, does that mean that the whole population has a correlation because of the sample's correlation? So that's what we're trying to test. So just a couple of key values we need to know. This R value here, we write it as the PMCC for the sample. So this is what we get from the sample. And this symbol here, this is pronounced as rho. And this just represents the PMCC value for the whole population. So this is what we're trying to test. Right, so as we've looked at in the hypothesis testing videos, we have the H0, H1. H0 being the null hypothesis and H1 being the alternative one. So we have to assume for H0 that rho is zero, i.e. we have to assume there's no correlation, right? Because we just don't know anything about the population. And then for a one-tailed test, then we see if rho is bigger than zero or rho is less than zero. So that's a one-tailed test. It doesn't tell us the value of the correlation, it just tells us if it does have a positive or negative correlation. Now for a two-tailed test, it just suggests that same thing, H0 rho is zero, H1 rho is not equal to zero. So we don't know whether it has a positive correlation or a negative one, we just know that there is some sort of correlation. Right, so when we do this testing, we have our R value, which we found from a calculator, and now we need to compare this with the critical value, right? So we have to find the critical region. And that's shown by this table here, which you'll be given in the formula booklet. So there's key values to note, or the key points to note is first things first, is sample level, okay? So this just represents the number of this N value here, which represents the number of data in the sample, which they will give you. Once you find the appropriate N value, then you look at this level here. As you can see here, it's like this represents on the top this significance level, which we also looked at. So make sure you choose the correct significance level and this correct rho, and then that way you can find the critical R value like this. You'll notice here that all these R values are actually positive values, but it's just positive, but it can also be plus or minus depending upon the test. Is it a one-tailed test lower or one-tailed test upper? So it just depends upon the test itself, but they're all going to be positive or negative values. The most important thing is the magnitude of this value. And so we need to know when to reject it. So we reject it when the magnitude of this R value, i.e. the R value, the PMCC value we get from the data, the sample, is larger than this critical R value here. This can be explained by this bell curve here as well. So if you look at this bell curve here, and now in this case, with this middle part is going to be zero, where there's zero correlation, and this is going to be -1, this is going to be +1 for negative and positive correlation. And so if we have a critical R value here, let's say this is the critical one, okay, and let's say this is the critical one here, then we'll reject it if the R value are in these sections here, right? When the sample's PMCC value is in this section here. So we reject it when the magnitude of this PMCC value for the sample is greater than the critical R value found from the table. Right, let's try this question here. So we have a scientific researcher who collects data on the amount of solvent in a solution and the rate of reaction. She calculates the PMCC value between the two sets and finds it to be -0.43. So the R values she found as -0.43. So this is the value they got from the sample. Given that she collected data from 15 samples, meaning that N is going to be 15, test at the 5% level of significance, so alpha is 0.05, whether there is a negative correlation between the two amounts. So first things first, H0, H1. So we have to assume that there's zero correlation for the whole population, rho is zero. And she's saying test whether there's a -1, so rho will be less than zero for this H1. Now, we found this R value here, so we need to find the critical R value, And as you can see, N is 15 and alpha is 0.05. So we can go back up here and then look for when N is going to be 15, hit this value here, and when alpha is 0.05. And as you should notice, we get 0.4409. So the critical value is going to be 0.4409. But because we're looking at a negative correlation, we can just write a negative sign in front of here. Once we've got the critical R value, now we compare the two values, right? So -0.43 and -0.4409. -0.43 is actually going to be greater than this -0.4409, which means that we do not reject the null hypothesis, okay? Because the magnitudes are not greater. So I can now conclude in context of the question. So it says what we're testing. We're testing the relationship between the solvent and the rate of reaction. So we can say there is So now I can conclude in the context of the question and suggest that there is insufficient evidence to suggest a negative correlation between the solvent and the rate of reaction, meaning that there's going to be no correlation. Okay, let's try another one here. So an ice cream seller believes that there's a positive correlation between the amount of sunshine and sales of ice creams. He collects data on 6 days. Calculate in A the PMCC value. Okay, so once again, just using a calculator, we just calculate this and you should get a value of 0.940. Carry out a hypothesis test at the 5% level if there's significant evidence in the support of the ice cream seller's belief. So first things first, H0, H1. H0 row is 0, H1 row is, if she's suggesting that there's a positive correlation, so row is larger than 0 like this. The significance level alpha is 0.05 and n is going to be 6 because there's 6 samples in this data here. And then we can now work out the critical value from the table, the critical R value, and you should get a positive 0.7293. Now our value of 0.940 is larger than 0.7293, so therefore we are going to reject this H0, meaning that the ice cream seller's theory is correct. It does mean as the amount of sunshine increases, his sales would also increase. And let's just try one final one. So as part of a survey in a particular profession, age and year salary are recorded. The values for X and Y are randomly selected of a sample of 10 members of the profession are shown below. Calculate the PMCC value for part A. Once again, just putting into a calculator, you should get a value of 0.340. So this part is relatively simple. Right, B. It is suggested that there is no correlation between the age and salary. Test this suggestion at the 5% level. So H0, same thing, row is always going to be 0. Now H1, as you can see, they're suggesting that there's no correlation. That means that row is not going to be equal to 0. That's what they're suggesting, okay? And so now we can say N is 10 members, alpha is going to be 0.05, and now we find the critical R value, okay? Now one thing to remember for this one, for a two-tailed test, remember, the two-tailed test suggests that there's two critical regions here and here. So if this alpha is 0.05, then remember that we have to divide each section by 2. So this section would now be 0.025, and this section will also be 0.025. So when you're looking at the table, you should look at when n is 10, but when the alpha values are going to be 0.025, not 0.05. That's just one thing you have to be aware of. And if you do find that, you get a value of plus or minus 0.6319. In this case, we have to write plus or minus because it's a not two-tailed test, so we don't know whether it's a positive value or a negative value. We have to compare it with just PMCC value, which we got above. So the PMCC value we got for the sample was 0.340, and that's less than this positive 0.6319, which means that it's not going to be in the critical region, so we do not reject H0. Okay, so this hypothesis testing for zero correlation is relatively simple. There's not too much to it. It's just making sure that you write all the different steps and write your conclusion very clearly.